All right. Graphing. Where is the breakpoint of this function going to be? It's going to be wherever what's inside the parentheses is equal to 0. So, -3. Now, two ways you can do this. XY chart, and you're golden, as long as you center it at -3. Or, what's the parent function here? X cubed, which looks like this, right? It's going to shift left 3, down 2, and then what's the negative outside the parentheses do? Flips it over which axis? So flips it vertically over the x. So it should look something like that. Let's take a look at it using XY points. So that's what it should look like when we're done, just by knowing those principles. But if we start at the point -3 and go on either side of that, so -2, -4, -1, -5, plugging -3 into the function, you should get -2. Punching -2 into the function, you should get -2 plus 3 is 1, cubed is 1, -1 minus 2 is -3. Plug -1 into the function, that's 2 cubed is 8, -8 minus 2 is -10. Plugging -4 in, that's -1, cubed is -1, minus -1 is +1, minus 2 is -1. Let's see, -5. It's going to be -2 cubed is -8, +8 minus 2 is 6. Let's plot this thing. -3, -2. -2, -3. So it did flip over. -1, -10 is like way down here. -4, -1, and -5, +6. Connect the dots. So it looks like it flipped it over vertically, but it didn't actually flip it all the way over the axis. So you might have to grab some points. That's right. That's right. Had the vertical, had this whole thing been in parentheses and made negative, this would have applied to this as well, but it didn't. That's why it only applied to the flip of the graph, not the vertical shift. So that's why it's always good to do XY points to verify what you're looking at. The inverse. Now there's two ways you could have done this. What's one way somebody chose to graph the inverse? Yes, ma'am. Flip the coordinates. Easy peasy. What's another way you could do it? Switch the x and y, solve for y. Actually find the inverse of the function. And then just graph. That's another thing you could do. But let's just flip the points and do it like that. Let's see. -10, -1. Holy mackerel. It's going to be like here-ish. -3, -2. Wait, no. I'm sorry. Yeah, that's right. -2, -3. That's weird. -1, -4, and 6, -5. Connecting the dots. That's a little too high. It's going to come down through there. And there's the inverse. And although it's hard to see, hopefully you can somewhat visualize that it is symmetrical around this imaginary line, which all inverses should be. If you turn your head, it should be. I'm not a very good artist, so it probably would be better. But anyway. So, easiest way to graph an inverse, graph the original, flip the coordinates. Questions? Great. Put those up. We'll have a new DOM tomorrow. Only days we won't have DOMs are on test days. And on those days, you'll just write test day. Today is, I kind of think it's funny they put this at the end of the chapter. I think it's kind of a wind down section because it really has nothing to do with anything we've been doing. In fact, sometimes I even skip this, but then we'd have to be reviewing for your test tomorrow. So I thought I'd give you one more buffer day. We're going to go ahead and do this. Although it has nothing to do with what we've been doing. Everything we're doing today is kind of review. Well, at least most of it. Distance between each pair of points. What formula do you need to find the distance between them? I heard a bunch of mumbling. Hopefully one of those things was the distance formula. The distance formula back from geometry. I don't even remember if this is on the test. I don't remember, but we're going to go ahead and learn it like it is. Distance formula. We'll do a straightforward example, and then we'll do a radical example. Let's do number 7. Number 7. x2 minus x1 squared plus y2 minus y1 squared. So that's 3 plus 2 is 5 squared. 4 plus 6 squared. Don't need this. And you should get radical 29, which you can just leave like that as the distance between those 2 points. Hold the phone. Oh, that's right. We'll look at one more. Are there questions on that one about any step we took, how we got a number? I'm not going to move it. I was just going to do number 15 in blue so that you guys can see some radicals. y2 minus y1 squared plus y2 minus x2 minus, I can't talk. I don't know why I'm doing my y's first. I'm in slope mode, and I apologize. But nonetheless, I just did the y's first. Don't know why I did that, but I did that. Squared. Why did I put this all in the same? What am I doing? Sorry. Distance formula? Oh, yeah. One good thing about this book, every single odd problem, there's like an even problem almost identical to it. So, if you see it up here, you're probably going to see something a lot like it. What's 4 radical 5 minus 1 radical 5? 3 radical 5, which we will then be squaring. Negative radical 3 minus 3 radical 3? Negative 4 radical 3, which we will also be squaring. So, what's 3 squared? What's square root of 5 squared? Well, that's negative 4 squared. Square root of 3 squared. 45 and 48. That's what I'm getting. Square root of 93. Distance formula. Uh, 3 and 91. Does it have any others? I think those are both prime. 3 and 31, I mean. 3 and 31. I don't think so. You could write it as decimal. What's it say in the top? It says, oh, yes it does. Take it to decimal, 2 decimal places. So if you have a calculator in front of you, maybe you can tell me exactly what that is. I'm going to guess like 8.7, but that's totally a guess. 2 decimal places. 8.72. Feeling froggy today. 72. What is it, someone? Dang. Wow, I was way off. Oh, I knew that. 9 squared is 81. Okay. Questions? You can borrow one. Yes. Only because if it's going to say that here, it'll probably say it on a test. You might as well get the hang of it. Questions from this slide? Radical 3. Because radicals, when they have a coefficient in front of them like this, like 4 and a 1, they play like x's, like 4x minus 1x. The x's wouldn't cancel, it would just be 3x. Same difference. I'm going to click on, click. Find the midpoint. Ooh, midpoint formula. Anybody remember the midpoint formula? Oh, I bet somebody remembers it. It's just the average of the x's and the average of the y's. That's all it is. Two separate coordinates. And we did a radical one last time, so we'll do a fraction one this time. We'll do 25 and 23. Let's start with 23. So x1 plus x2 and y1 plus y2, which is 3 over 2 and negative 12 over 2, and there's your coordinate. And then we'll look at 25 after this. Ooh. No, we won't. We're going to look at 29. Nope. Yep. Questions on that one? 29. So it's the radical of 18 plus the radical of 2 over 2, comma, negative 4 plus 4. Whenever they give you two different radicals, they don't want you to just leave it. Most likely if they give them to you, it's because one of them can reduce. Which one of these radicals can reduce in any way? The 18, which is the same as square root of 9 times square root of 2. Square root of 9 is just 3. So 3 radical 2 plus 1 radical 2. 4 radical 2 over 2, which I'll reduce in a second. Negative 4 plus 4 is 0 over 2. So going one step further, what is 4 radical 2 over 2 reduced to? 2 radical 2. Just the 4 and the 2 cancel, and then this would just be 0. So that is your finished coordinate. If they give you radicals, it's because it's a simple reduction to get them to be the same. They shouldn't give you odd radicals today. Take a gander at the board. Is there another problem someone would like to see? $27. Excellent. 27. x1 plus x2 over 2, comma, y1 plus y2 over 2. So that's going to be 2 over 2, which reduces to 1. 3 radical 5 plus 7 radical 5 is how much? 10 radical 5. 10 radical 5 over 2 becomes 5 radical 5, and that is your coordinate.
How did you get 4 radical 2?
The green one? Yeah. Well, this is kind of confusing the way I'm doing it because I'm doing x, y, x, y, x, y. So really, none of that has anything to do with it. First thing, I broke this down into the square root of 9 and the square root of 2, which then became just 3 square root of 2. So I had 3 square root of 2 plus 1 square root of 2 gave me, yeah, that was it. So then that reduced to just 2 square root of 2. Other questions? Good question. Just like the x, see, think about it like this. 3x plus 7x is 10. Other questions? These are all good questions. All right. Standard form, the equation of a circle. Who remembers the equation for a circle? It is who can tell me what H or K stand for? What was it? It is the center. It is the center. H and K is the x and y coordinate of the center of the circle. So, let's just look at number 33. Actually, let's look at 35. 35 would be x minus -1, which is the same as +1 squared. Y minus 4 squared equals 2 squared. H and K is the center, but see, since you're subtracting, you basically just take the opposite of what it is. So -1 becomes +1, +4 becomes -4. Then you just square the radius, and there's your last number. Let's take a gander at 37. X plus or minus what? +3, because it's already negative. Then what? Y plus 1. What's the square root of 3 squared? 3. That's it right there. That's all you have to do. Next, we're just going to be given the formula and asked to go backwards. Find the center and the radius. You don't have to FOIL. You don't have to do anything like that. However, I don't think I included it on the next slide. I did not. So I will... Hold on. Make sure I didn't put it on here. No, I didn't. One thing that I evidently accidentally left out of this. If we were to FOIL and stuff, wouldn't this be x squared plus 6x plus 9 plus y squared plus 2y plus 1 equals 3? The only thing you can really put together are the two numbers, the 9 and the 1. If you bothered to FOIL that out, which you shouldn't. Don't do that. But you would get something long like that. I think you do have one today where it's long like that already, and it has to work backwards. You know what? Let me just try to find one. No point in me trying to sit here and explain it. Let me go ahead and do these next 4, or next slide, and then maybe we can go back and find one. Let's see. What is the center of 43? It's the opposite of the number. So if it's negative, it's going to be positive. And what's the radius? Muy bien. What about 49? Center. 49. What's being 0, because there's nothing being subtracted, and then 1. Well, let's see. Give the center and graph each equation. We'll get to that in a second. Use the graph to identify the relations domain and range. Let's think about this for a second. Better yet, let's graph one, and then we'll come back and look at those. Here's one. What's the center? -3, 2. Radius. Oh, that might help if I uncovered it. So it's going to go out 2 in every direction. Now, on those problems, you don't actually have to list the center of the radius. If your graph is accurate, then obviously your center and radius will be accurate. So you don't have to list them, just graph them, and that'll tell me what I need to know. Now, the domain is going to be, looks like -5 to -1. And the range is 0 to 4. Now, what's an easy way? Somebody raise your hand and tell me, what's a way you could look at the equation and figure out what the domain and range could be? Because you might have one on a test where it just shows you this, it says domain and range, and you may not want to take the time to graph it. What's a simple way you think we could figure out the domain and range? What's that? Close. You're not actually going to use the 3 and 2 together. Wow, these are all crazy things that I think would actually work, but I think it's just a fluke itself. What's the way you could do this? I'll give you a hint. You're not going to use the 3 and 2 at the same time at all. Well, think about it. Isn't this the center? -3, +2. And how far are we going from the center at all times? 2. Right? So, just take the center, -3, 2, and just go out 2 in every direction in your mind. First the x coordinate, -3. What's 2 less and 2 greater than that? -5, -1. What's the y coordinate? 2. What's 2 greater and 2 less than that? 0 and 4. So, you know, little logic things like that might save you time in the future. But since you have to graph them, I guess that doesn't serve really a purpose. That's why I was going to go back and show you, but I don't guess we have to do that. Questions on the graphing? Only thing I need is the graph, the domain, and the range. Everything else will be kind of included. Yes, here we go. This is the ones I was talking about earlier. Apparently I did it. You know what? I don't feel like doing this. Not the last day forecast. We're just going to skip this. 53 through 6. Okay. Find the coordinates of the center of the circle. I give you a hint. This is kind of a review of everything we've done today. How are we going to find the coordinates of the center? If it gives you these, midpoint. Yes. The midpoint of those 2 points will be the center. I think that's 5, 10. Find the radius of the circle. How? If you know the midpoint is 5, 10, how can you find the radius? Distance formula. I don't know if that's what was said back there. I couldn't hear. Distance from that point to this point, or this point, doesn't really matter which one, will be the length of the radius. And then use your answers to write the equation of the circle. We can do that real quick. Let's see. The center, after you do the midpoint, what's that? The center to this point, so we have to find the radius. So x2 plus x2 minus x1, y2, oops, I did them in the backwards order. Shouldn't matter though. Minus y1. 2 squared is 4, 1 squared is 1. The square root of 5 is the radius. The equation of the circle is going to be what? X minus 5, y minus 10 equals the radius squared. Very good. I'll give you a hint. You're going to have to do 66, and it's going to be just like that. Midpoint, distance, put them into the equation. Questions? I believe we only have one more slide. Is there a question? No? Okay. Graph both equations, then show that these ordered pairs satisfy the equation. Okay, so basically I just want you to graph both and try to eyeball their intersecting points. So that's what I'm going to do. Let's see. Let's just take this thing with us. Cut. New page. There we go. Okay, here we go. What is the center of the circle? Center of the circle. 0, 0. What's the radius? So 1. Connect to the dots. Best circle I've ever drawn in my entire life. And last but not least, graph the line. How are we going to graph this line? Exactly what we're going to do. Isolate y. Add the y, subtract the 4. So that's going to be negative. Now, most of the coordinates where it's going to connect are going to be really obvious. And let's see. slope of 1 if that's the way you want to do it, or you can make an XY chart. Boom, 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 boom. Connect the dots with your line. And where do they intersect? At what coordinate? 0, -4, and 4, 0. You can just eyeball them, list the coordinates, and that's it. Questions? Here you go. Hold on, I have to edit that. Oh man, it's me. That's right. You can't buy 6s. But you know what? I'm just going to write out those problems because I'm going to take some out. Don't write that down yet. I'm actually going to write down the problems you have to do. That would be 2, 8, 14, 20, 26, 32, 38, 44, 50, yeah. Here you go. Those are, well, until the end. The numbers mess up at the end. So you have those 1, 2, 3, 4, 5, 6, 11 problems, and then these are review. Those other ones are going to be reviewed, but they are required on your assignment. Yes, it is. It is 1.9. Please write 1.9 really big atop your paper. And Sarah in a moment.